Okay, so when we multiply a vector by a scalar, remember scalar was just a distance, right? It's a distance without specific direction. If we take a scalar and we multiply that times a vector, like example 3 times vector A. 3 times vector A is said to be 3 single vector A's lined up in a row. So let me give you an example of what I'm talking about. Let's say that I had the vector 2i plus 3j, and that's vector A, right? And I wanted 3 vector A's. Then 3 vector A's would be 3 times 2i plus 3j. Yes?
Does it mean like the magnitude is like multiplied by 3, but what was it again? The direction is still the same.
Yes, exactly.
But the angle is still
Yes,
the same.
exactly. So this would end up being 6i plus 9j. Now let me show you how that might look when we're actually graphing. Let's take 2i plus 3j. So we're going to go 2 to the right. We're going to start at 0, 0 because they did not tell us when they gave us the direction. They gave us the vector 2i plus 3j. All they told us was that it was 2 to the right and 3 up. And they didn't tell me where, so we assume that it starts at the origin, 2 to the right and 3 up. And that is vector A. Notice how I drew the arrow. I had my initial and I showed where it terminated, my initial point and my termination point. If I have 3 of that, and so that I ended up, I'm going to move this down so you can see it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh boy. 6, 9 is going to end up right here in the middle of my number. I'm going to put it right there just a little bit so you can see it. Right there. This is 3 vector A's. And if I found the magnitude of this first one, well, that's the square root of a squared plus b squared. So that would be 4 plus 9, which would make this a distance of root 13, right? This would have a magnitude of root 13. This would be 36 plus 81. Well, 36 plus 81, somebody do that for me.
36 plus 81.
Mm-hmm.
117.
117, which is 9 times 13, which is 3 root 13 for a magnitude. So the magnitude is 3 times as long. Now, the angle, however, is still the same. How do I know that the angle is still the same? Because the slope is still the same. The relationship between the y values and the x values is still the same. So it's just 3. I could actually even make a pit stop along the way. 1, 2, 1, 2, 3, 1, 2 from there, 1, 2, and I drew it kind of badly to get in the picture. 1, 2, 3. That's like there's vector A, there's vector A again, there's vector A again. That's 3 of vector A. Make sense? Okay.
So what is the end of the sentence? When multiply a vector by its scalar?
When you multiply, when you multiply a vector by a scalar, what you are doing is creating 3 of that initial vector.
So scalar is kind of like a coefficient for a vector.
Yeah, it's a multiplier. It's a scale factor. You know, when we talked about dilation, we called it a scale factor. So that's why you have a scalar. Okay? To add vectors, okay? To add vectors, line them up. end to end. And that means that one starts where the other one ends. The sum creates a third vector. That third vector is the resultant vector. Okay, we call that third vector the resultant vector. So let me show you what I'm talking about. Let's say that I have vector A. Here's vector A. And I want to add that to vector B. Right? This third vector that shows me where I would end up. Notice where it started. It started at the beginning of A, and it went to where B ended up. And that is called the resultant vector. So using some real examples, let's say that I had vector A, which was equal to 2i plus 3j. And I'm just going to use that one because I had it before. And I've got vector B, which is 3i plus 5j. If I added them together, that would be vector A plus B. And notice how I'm going to mark that. It's vector A plus B would be 5i plus 8j. Now what that means is if I'm graphing this, and I started at the origin, and I went right 2 up 3, put a point for the end of A, and then from there, I went right 3 up 5, that the final point would be located at right 5 up 8. Now, some people are saying, all right, I get that, but why are we not just adding coordinates? 2 comma 3 plus 3 comma 5 equals 5 comma 8. And that's because I'm telling you which direction you want to travel. I am giving you, with the vector, which one comes first, okay, and which one comes second. Now, that makes a difference because understand that vectors add together in a commutative way. They do not subtract commutatively. You get different answers. Let's talk about the opposite of a vector. If vector A is equal to 2i plus 3j, then the opposite of vector A would be negative 2i minus 3j. And that's that, you remember we talked about earlier that if I went right and up or if I went left and down, it's the same magnitude, but it's a completely different vector. It also implies you're starting at a different origin point. Okay? So let's look at a couple of examples of vectors that we're going to actually add together. So given that I have vectors A and B, and they want me to sketch the resultant vectors A plus B, all right? And somehow this didn't get labeled, but this one is vector A, and this one is vector B. Notice location isn't nearly as important as the fact that you have a starting point, an end point, a starting point, and an end point. So to draw them together, I'm going to move over here to the side just a little bit. And I know that A is right 1, 2, 3, up 1, 2, 3, 4. So I'm going to pick a point, and I'm going to go right 3, 1, 2, 3, up 1, 2, 3, 4. And I'm going to call that vector A. Since it's the same direction and it's the same distance, it's an equal vector. Even though I moved it, the angle off of the polar axis would still be the same, right? And the distance is still the same. And when I add B to that, I'm going to go from the end of A, I'm going to go, we lined them up head to tail, or actually, yeah, head to tail, the tail of this one to the head of B. And so we're going to go left 2, up 2. So from there, I'm going to go 1, 2, left, up 2. And that is